Finding the square root of a perfect square is very easy, and the problems that we've done so far in this unit have all involved perfect squares inside the radical. For example, the square root of 16 is 4, and the square root of 289 is 17. But what happens when you have a number inside the radical that's not a perfect square? For example, the square root of 57. In order to estimate this or approximate this to the nearest whole number, we're going to follow 3 steps. The first step is we're going to find the 2 perfect squares that the given number falls between. So we're going to look at this list we have of the first 20 perfect squares, and we're going to find which 2 perfect squares 57 would come in between. And that would be right here. 57 is going to come between 49 and 64. So I'm going to list both of those. 49 and 64. So that's my first step. After that, I'm going to determine which perfect square is closer to the number that I'm trying to find. So the difference between 49 and 57 is 6 on this side, and the difference between 57 and 64 is 7 on that side. So 57 is actually closer to 49 than it is to 64. Not much closer, right, but it's a little bit closer. So once we determine which one is closer, I think it's a good idea to circle it so we know which one we're looking at. So now we finish the second step. The third step is, now that we've determined which one is closer, we're going to find the square root of that number. And the square root of 49 is 7. So if I was going to estimate the square root of 57, I would say that the square root of 57 is approximately, we're going to do a squiggly equal sign, is 7. Okay, let's try a few more examples now. The square root of 74 falls between the square root of 64 and the square root of 81. The next thing I want to do is I want to see which one is closer. So the difference between 64 and 74 is 10, and the difference between 74 and 81 is 7. So that means that 81 is closer to 74 than 64 is. So the square root of 81 is my closer estimate. When I write my answer, I'm going to write it like this. I'm going to say the square root of 74 is approximately 9. And the reason it's 9 is because the square root of 81 is 9, and that's the one it was closer to. Our next example is the square root of 350. So this one comes between the square root of 324 and the square root of 361. So again, we're going to look at the difference between them to decide which one's closest. 324 and 350 have a difference of 26, and 350 and 361 have a difference of 11. So that means that the square root of 361 is closer to the square root of 350. The way I'm going to write my answer is I'm going to say the square root of 350 is approximately 19, because the square root of 361 is 19. And all we're doing right now is we're just rounding to the nearest whole number. So the last example is so easy. I'm not sure why there's such a simple example at the end, but let's just enjoy it. The square root of 2 falls between which 2 perfect squares? Well, that would be the square root of 1 and the square root of 4. So then we look at them more closely to determine which one is closer to the square root of 2. Well, the difference between 1 and 2 over here is only 1, and the difference between 2 and 4 on the other side is 2, so the square root of 1 is closer. When I write my answer, I'm going to say the square root of 2 is approximately 1, because the square root of 1 is 1. Okay, let's try some examples now of approximating each square root to the nearest tenth. This is going to be a little bit more difficult because we're not rounding this time to the nearest whole number. This time we're going to be rounding it to the nearest tenth. So we've got a couple more steps that we have to do, but I've listed them all at the bottom. We'll go through them one at a time. Okay, for our first example, the square root of 158. The first thing we have to do is we're going to list the 2 perfect squares that 158 falls between. So that's going to be the square root of 144 and the square root of 169. So that's step 1, just like we did before. The next thing we're going to do is we're going to find the difference between each of these perfect squares and the number that we're trying to find. So the difference between 144 and 158 is 14, and the difference between 158 and 169 is 11. So that's step 2. Now we're on step 3. We're going to add those two numbers to find the total difference between our two perfect squares. In other words, the total difference between 144 and 169. So we're going to add 14 plus 11, and that gives us 25. Now we want to make sure we keep that number handy because we need that for step 4. So now we're on step 4. It says we are going to divide the difference of the perfect square that comes below the given number by the difference between the two perfect squares and round to the nearest tenth. So let me just explain that step by step. What we're going to do now is we're going to take this difference, the one that came between the lower perfect square and the number that we were trying to find, which is 14. Then we're going to take this total number right here, which was 25, and we're going to divide those, and that's going to give us a decimal. So 14 divided by 25 is going to give me 0.56 as a decimal, 0.56. I'm going to write that down. All right, so now let's go back up and let's answer our question. The square root of 144 is 12, and the square root of 169 is 13. So that means that my answer is going to be somewhere between 12 and 13, right? It's going to be 12 point something. So here's my 12, here's my point, and we just figured out what the something is going to be, right? Because we divided 14 by 25, and 14 divided by 25 gave us 0.56. So all I need to do is I need to take this 0.56, and I want to round this to the tenth. So is it going to be 0.5 or 0.6? Well, it's going to be 0.6, and that's what I'm going to put on the end of my 12. So my estimate of the square root of 158 to the nearest tenth is going to be 12.6. Okay, let's look at the next example. So the square root of 39, that's going to fall between the square root of 36 and the square root of 49. That's step 1. Now for step 2, we're going to find the difference. The difference between 36 and 39 is 3, and the difference between 39 and 49 is 10. Then we're going to add those together, right, to find our total difference. So 3 plus 10 gives me 13. We're going to keep that number handy because we need that. So the next thing we're going to do is we're going to take the difference between the lower perfect square and the number we're trying to find, which is 3, and the total, which is 13, and we're going to divide these to get a decimal. So 3 divided by 13 gives me 0.23. When I go to write my final answer, I'm going to say to myself the square root of 36 is 6 and the square root of 49 is 7. Therefore, the square root of 39 is going to be somewhere between 6 and 7. It's going to be 6 point something. Now, I don't want to write 6.23 because I want this rounded to the nearest tenth. So if I'm going to round 0.23 to the nearest tenth, I'm just going to make that 0.2. So my estimate is 6.2. Okay, let's do our last example. We've got the square root of 285. So that's going to come between the square root of 256 and 289. And you can just look right on your list of perfect squares for this. We're going to find the difference between each. So the difference between 56 and 85 is 29, and the difference between 285 and 289 is only 4. Then we're going to add those together. So 29 plus 4 is a total difference of 33. In order to get my decimal, remember, we're going to take the difference between the lower perfect square and the number we're trying to find, which is 29, and we're going to put that over 33. So we're going to do 29 over 33. So 29 divided by 33 equals 0.87 repeating, right? 0.878787. So when I write my final answer, because the square root of 256 is 16 and the square root of 289 is 17, I know my answer is going to be 16 point something, right? It's got to come between 16 and 17. I'm going to look at my decimal that I figured out, which is 0.87, and I'm going to round that to the nearest tenth. So if I'm going to round to the tenth, then I'm going to look at the next one to help me decide. Since this is higher than 5, that means that's going to become 0.9. So 16.9 is going to be my approximation to the nearest tenth.